Here's lesson 7 on solving absolute value inequalities. So we want to remember that an absolute value is the distance away from zero on a number line, just like it was with absolute value equations. So an absolute value inequality is going to be the same as a compound inequality, and you'll see what I mean. What we're going to do is we're going to end up breaking these absolute values up into two cases, just like we did with equations, and we're going to be able to separate them with the word and or, just like a compound inequality. So we're going to rewrite absolute value inequalities as compound inequalities separated by the words and or. In the first example here we have the word and, so absolute value of A is less than B. Whenever we see less than or even less than or equal to, we are going to separate the absolute value inequality with the word and. In other words, you can write it like this as one inequality, kind of doubled up like that. Or we could say this: negative B is less than A and A is less than B. So we could write it either way. When we have greater than or equal to, you'll have the absolute value of, when you break it up into two parts, you'll have A is less than negative B or A is greater than B. Thing to remember is when we have a number line, the and one is always going to be this kind of middle section, and the or ones are always going to go away from each other like this. Okay, so when we graph, you'll see it'll work out to be the same as what we were doing the other day with just regular compound inequalities. Let's start with the less than and less than or equal to. So less than or equal to is and. Okay, so and means you can write it with the word and. You're going to have the number line with the two graphs going towards each other. And we can write it as one inequality if we want to, or we can write it as two inequalities with the word and. So I'm going to first write it as one inequality. The way we do that is we're going to say we're looking for the distance away from anything that is 2 units away from 0, okay? So, and of course that center is going to change because we have this -1 on the inside. But so what we want to do is we want to know that we're looking for any distance that's almost 2 units, because it's just less than, or it could be 1 unit, or anywhere in between. Okay, so if you think about it, what we want is anything between -2 and 2. So in other words, we want this. We want n-1 to be between -2 and 2. So now let's break this into its two parts. So like case 1 and case 2. So case 1 is going to be this: -2 is less than n-1. Case 2, so case 1 is that. Case 2 is n-1 is less than 2. And all I did was take this part first, and then I took this part second. Okay, so let's solve this. So if I want to get n by itself, I add 1 to both sides, telling me -1 is less than n. Over here, I'm going to add 1 to both sides, telling me n is less than 3. Okay, if you want to, you can write this one so that n comes first, which would say n is greater than -1. If you want to be able to read it from left to right, that's fine. So let's take a look at our number line. Oops. Let's take a look at the number line here. Let's find 3, and let's find -1 somewhere down here. So 0, 1, 2, 4 would be over here. -2 would be over here. I'd have arrows on the ends. Let's graph. So let's graph this one first. So n is greater than -1. So it's going to be an open dot at -1. And I want things that are greater than -1. Let me substitute something in, like 0. Is 0 greater than -1? The answer is yes. So I'm going to end up shading that way. I want to wait a second before I do it though. Let's see what this one is. N is less than 3. So I want to put an open dot at 3 because it's less than. Let's find a number. Let's try 4. Is 4 less than 3? The answer is no. So I want to shade away from 4 going that way. And what's going to happen is these two are going to connect when I shade. So solution on a number line looks like that. And this should look familiar from the just compound inequalities that we did the other day. Let's try a less than or equal to question. Again, less than or equal to is the same thing as and. And so we can break this into two inequalities, or we can write it as 1. So let's write it as 1. Negative 9 is less than or equal to 2c minus 5, which is less than or equal to 9. If you don't like that, we can write it into its two cases, case 1 and case 2. So case 1 is going to say negative 9 is less than or equal to 2c minus 5, where case 2 is going to say 2c minus 5 is less than or equal to 9. Solving case 1, I would add 5 to both sides, giving me negative 4 is less than or equal to 2c. Dividing by 2, dividing by 2. I think for a minute I'm dividing a positive value. I don't need to flip the sign. I get negative 2 is less than or equal to c. Over here on the right, I will add 5 to both sides, telling me 2c is less than or equal to 14. Dividing by 2 tells me c is less than or equal to 7. So let's come down to the number line and graph this. So I have 7 somewhere over here. I have negative 2 somewhere over here. So negative 1, 0, 1, 2, 3, 4, 5, 6, 8 would be here. Negative 3 would be here. Let's start with this one. Negative 2 is less than or equal to c. So I'm going to put a closed dot at negative 2. And I want values that are, well, let me try something. So let's try negative 3. Is negative 2 less than or equal to negative 3? Nope, negative 2 is more than negative 3, so I want to go away from negative 3. I want to go this way. Let's graph this piece. C is less than or equal to 7, so I have a closed dot at 7. Let's pick a number like 4. Is 4 less than or equal to 7? Yes, it is, so I want to shade towards 4. So again, I now have this whole section in between my two dots that gets shaded, and that's the graph of this absolute value inequality. Big thing to remember here is that when we have less than or less than or equal to, it becomes and. So, like you might expect, greater than or equal to is going to be or. So let's see what happens when we do an OR problem. We have 8n is greater than 24. So that's going to be the absolute value of 8n. So let's see. So we just have 8n is greater than 24, or 8n is less than negative 24. So over here, let's divide both sides by 8, giving me n is greater than 3. And over here, let's divide both sides by 8. I'm dividing by a positive. I should be fine. So n is less than negative 3. Okay? Again, what two numbers are 24 units away from 0? You know, you think about it like that, and you have 24 and negative 24. So that's how you find out what goes here and here. You keep the greater than for one of them, and you go to less than for the other one. Okay? So less than goes with the negative in this case. So let's see what happens. If I have 3 over here, negative 3 over here, so negative 4, I'd have positive 4. Negative 2, negative 1, 0, 1, 2. Let's graph this one first. n is greater than 3. So a open dot at 3. I want stuff greater than 3, so like 4, 5, 6. So I'm going to end up shading that way. Let's see. N is less than negative 3. So I want things smaller than negative 3. So I want to go this way, like negative 4, negative 5, negative 6. So let's shade that way. And let's shade this way. And now we have the OR style inequality where the two arrows go away from each other on the number line. This is just like the other day when we looked at compound inequalities with OR. So anytime we have greater than with an absolute value, we are going to end up with an OR statement. And our number line should go away from each other. Let's try this greater than or equal to. So we have the same idea. So 5t minus 4 is greater than or equal to 16, or 5t minus 4 is less than or equal to negative 16. Okay, this is case 1 and case 2 again. So every time we see absolute value, you're always thinking I have two cases. That should always come into your head. I have two cases. And then we just have to remember that the greater than is like an OR type of compound, and a less than is an AND type of compound. So let's solve this. So I'm going to add 4 to both sides here, telling me 5t is greater than or equal to 20. Dividing by 5 tells me t is greater than or equal to 4. Solving the other side, I add 4 to both sides, telling me 5t is greater than or equal to negative 12. Dividing by 5 tells me t is less than or equal to negative 12 fifths. Okay, that's a little bit more than 2. I'm sorry, negative 2. That's like negative 2 and 2 fifths. Negative 2 and 2 fifths. Okay, so let's see where these are on our number line. So I need 4. 4 is going to be over here somewhere. 3, 2, 1, 0, negative 1, negative 2, negative 3. So negative 2 and 2 fifths is going to be somewhere in the middle of those. T is greater than or equal to 4. Let's graph that. So it's going to be a closed dot at 4. I want values greater than 4, so 5 would be one of those. So I'm going to shade towards 5. And then let's look at this one. T is less than or equal to negative 2 and 2 fifths. So negative 2 is here, and 2 fifths is going to be somewhere between negative 2 and negative 3. Be careful you don't go between negative 2 and negative 1 here. This is more than negative 2. So more than negative 2 is over here. And it's going to be a closed dot somewhere around there. If you want to, you would label it negative 2 and 2 fifths. And then we want values that are, we want t to be less than that. So in other words, we want that to be greater than t. So that's going to send our arrow this way. Try the number 4. Or negative 4. Is negative 4 less than or equal to this? Yes, it is. Okay, so that's really all we have for absolute value inequalities. They're exactly the same as compound inequalities. You just need to remember which is which. You need to know that the greater than and greater than or equal to is an OR inequality, which means that our number lines are going to go away from each other. The graphs will point in opposite directions. And the AND one that we saw a minute ago right here, this is for less than or equal to. And these graphs are going to go towards each other. Kind of makes it look like dumbbells or something like that, like weights you'd be lifting. All right, that's everything, and we will work pretty hard on this next class. See you then.